Hi, today we're going to be discussing net ATP production from beta oxidation. So this question is asking how many net ATPs are produced from the oxidation of a C6 fatty acid. So here we have a drawing of a cell. Fatty acid synthesis occurs in the cytoplasm, whereas beta oxidation occurs in the mitochondria. Therefore, we must move fatty acids from the cytoplasm into the mitochondria before we can do beta oxidation. To do this, we have two stages. The first stage is mobilization, in which triacylglyceride is converted into free fatty acids. The second stage is activation, in which the free fatty acids are moved into the mitochondrial matrix. This activation step undergoes ATP hydrolysis. Recall that when ATP is hydrolyzed into AMP, it must undergo two phosphorylation steps. Each phosphorylation step corresponds to the net loss of 1 ATP, so two phosphorylation steps corresponds to the net loss of 2 ATP. After this, we can do beta oxidation. So here we have our pathway for beta oxidation. One round of beta oxidation produces one FADH2, one NADH, and one acetyl-CoA, except for the last round of beta oxidation, which produces two acetyl-CoA. In order to visualize this, I find it very helpful to draw it out. So here we have our C6 fatty acid. One round of beta oxidation will produce one acetyl-CoA, and another round will produce two acetyl-CoA. I find this drawing method to be very helpful when working with short-chain fatty acids, but when we're working with longer-chain fatty acids, it can get quite tedious and time-consuming. Therefore, there's a shortcut we can use. N divided by 2 minus 1 is equal to the number of rounds of beta oxidation. And here, N stands for the number of carbons in our fatty acid. So in ours, we're working with 6 carbons in our fatty acid, divided by 2 minus 1, which equals 2 rounds of beta oxidation, which we can see here in our picture. If we count the acetyl-CoA, we have 3 acetyl-CoA, and we will always have one more acetyl-CoA than the number of rounds of beta oxidation, since the last round of beta oxidation produces 2 acetyl-CoA. So I like to draw this little chart to keep all my work in one place. So we just said that we produce 3 acetyl-CoA. We also know that we have 2 rounds of beta oxidation, and each round of beta oxidation produces one FADH2 and one NADH. So 2 rounds will produce 2 NADH and 2 FADH2. For the number of ATP yield per metabolite, we know that NADH produces 2.5 ATP and FADH2 produces 1.5 ATP. But what about acetyl-CoA? If you'll recall, the citric acid cycle completely oxidizes acetyl-CoA. And it does this by releasing the carbons as carbon dioxide. Looking at the citric acid cycle, we see that we produce 3 NADH, 1 FADH2, and 1 ATP. When we account for the ATP production from the citric acid cycle, we get a total of 10 ATP produced. Therefore, the number of ATP yield per acetyl-CoA is 10 ATP. So now we just multiply across each row. So if we have 3 acetyl-CoA and each yields 10, we have 30 ATP from acetyl-CoA. If we have 2 NADH and each yields 2.5, we have 5 ATP from NADH. And if we have 2 FADH2 and each yields 1.5 ATP, we have 3 ATP from FADH2. And now we can just add these together, 30 plus 5 plus 3, which equals 38 ATP. However, don't forget to subtract the 2 ATP from the fatty acid activation step, which means we have a net production of 36 ATP from the oxidation of a C6 fatty acid. Go ahead and do this problem on your own and come back when you're ready to work through it together. So this question is asking how many net ATPs are produced from the oxidation of a C10 fatty acid. Again, I find it very helpful to draw this out. So one round produces 1 acetyl-CoA, a second produces a second acetyl-CoA, a third produces a third, and the fourth round produces the fourth and fifth acetyl-CoAs. Again, we can do our shortcut method with this. So n divided by 2 minus 1 equals the number of rounds. Here we have a C10 fatty acid, so 10 divided by 2 minus 1 equals 4 rounds of beta oxidation. Recall that we will always have one more acetyl-CoA than the number of rounds. So here we have 5 acetyl-CoA. Also remember, we have 4 rounds of beta oxidation, and each round produces 1 NADH and 1 FADH2. So 4 rounds will produce 4 NADH and 4 FADH2. These numbers in the ATP yield column will stay the same. So if we multiply 5 times 10, we get 50. 4 times 2.5, we get 10. And 4 times 1.5 is equal to 6. And now we can simply add these numbers together, 50 plus 10 plus 6, which gives us 66 ATP. However, we need to subtract the 2 ATP from fatty acid activation, so we end up with a net yield of 64 ATP from the oxidation of a C10 fatty acid.